So welcome and thank you for coming along. This room is far bigger than I imagined, and good to see a reasonable turnout as well. Very nice. So I'm here today to talk about, well, back to the future, taking Arduino back to its Java roots to move forward. My name's James Kasker, and I have a couple of products in the physical processing space, Virtual Breadboard and Muvium, and these two products work together and also separately and apart. But today we're going to talk about physical computing with Arduino. Welcome to the real world, Morpheus once said. So physical computing these days is getting to be a bit of a hot topic. Today we're flashing lights, making sounds, driving motors, reading sensors, and more connecting to the internet, interacting with the real world. But Java, by design, lives in a sandbox. So he doesn't get out that much. So it's not really been the natural choice for physical computing because of that reason. So, wrong way. Here we are. In steps Arduino. Now Arduino is sort of Java for the real world. It's become something of a de facto physical computing platform. But it's actually based on Java. It's got a Java IDE. Its syntax is also based on Java, but it's processed by GCC. So it's kind of a C in Java clothing. And it's become very popular, in part due to its Java origins. Let's see if I get this right. So, in Java we're used to the idea of hello world, but in physical computing, Blink is the hello world of choice. Blink is a program that ships with the Arduino. It's probably the first one that you did if you've used Arduino to make a light flash on and off. Arduino has a very simple structure to get started with. It has a setup and a loop. The setup is called first, and you use the methods or the functions of the Arduino platform to perform the input and output tasks. So in this example, you set up the pin mode as an output. You write to it, pin 13 this is, you write high, you wait a bit, you write low, and lo and behold, you have a flashing light. Now Arduino is great. It's got a really large library of examples. It's a great place to get started. It's got an enormous community and lots of references. But what next? Where does Arduino go to? It's kind of a bit of an island. So it's not quite C, it's not quite Java, and more importantly, the IDE itself isn't not extensible. Well, it hasn't been in the past. So when companies like Microchip wanted to join the party, and they wanted to introduce the chip kit, which is sort of an Arduino clone, they actually cloned the whole IDE rather than extend on what Arduino had done. So when you clone or fork a code base, of course, the maintenance issues start kicking in. And already, for example, we see that the MPIDE uses the older sketch file format, and the Arduino has moved on to the .eno file format. But Blink works pretty much the same way. Got to get used to this. Pardon me. MPIDE is not the only clone. Now we're seeing the Texas Instruments Launchpad as well, another clone. But maybe you didn't know that Arduino itself is a clone. It was a clone of the wiring platform, which introduced, I guess, many of the first concepts of the physical computing space before Arduino even. But wiring itself is also a clone of an IDE called processing. So processing began it all, really. So what was special about processing? Well, it's a simple Java IDE. It has, it's ideal for starters and casual programmers because unlike Eclipse or Netbeans, there's not 10,000 buttons to press, 10,000 options to choose from, which is literally, for a beginner programmer, puts you into a state of shock. But it does have a lot of built-in libraries, so you can get some good results very quickly. It's open source, diverse Java community, and it's cross-platform, which Java is. So these are the reasons that processing formed the basis of all these clones that have since come. But can the clones keep up? As we know, as Java programmers, any decently large project, once it gets forked, starts decaying. And Arduino, processing's done really well. It's continued its development path. It's now on to 2.0. And in fact, 2.0 has got some very nice features. It's processing itself is designed for extensibility, unlike Arduino has been. So it's being Java-based. One of the really nice things I like about it is the new auto-update management feature and the Eclipse templated library and tool plugin. And this allows you to, as a developer, build something that's going to be included in the life cycle and the life path of the processing platform. So processing is not an island. So this is where a little bit, I talk about going back to the future, this is where a little bit I want to go back to processing. So Frappuccino is a processing library, so it's built using the processing template. It's a 100% Java implementation of a physical computing platform. So we're going to extend processing, not fork. This way it can become part of a bigger part of the whole ecosystem, of the processing ecosystem. And right now, Frappuccino it's already a contributed library, so you can access it from the processing website, and it's maintained by Muvium. So to install processing, now, to install Frappuccino in processing, I should say, you use the regular library import mechanism inside processing. So once you've installed the Processing IDE, you simply go to the library manager and you add a library, and you find Frappuccino in the list, click install, and that's it. From then on, processing will alert you when there's new updates and install them automatically. Actually, the first time you have to actually restart processing for it to find the libraries. So what does Blink look like in Frappuccino? I have a bunch of demos here, but I'm being a bit safe by just going through the presentation first. If I have time, I'll come back and do some of these demos. But it works pretty much the same way. The processing template system has a built-in library manager. So when you install the template, you install the library, we'll also install the libraries that you can use as well, the examples. So what we've done here is we port, keep in mind, Frappuccino is a port of the Arduino runtime libraries and examples and physical processing environment. So you start Blink the same way. You open it from the library, you press run, compiles it, downloads it, and off you go. The difference is it's all Java rather than C, C#, C++, or some combination thereof. So let's have a bit of a look inside, Blink versus Blink. You're probably all familiar with the, if you've used Arduino, the format for the Blink. With the Frappuccino version, it's exactly the same, except we add a Java class wrapper. We import the Muvium processing package, which is part of the Frappuccino library. We extend the board that we want to use. That gives us our target, and we compile it and run it. So what's the difference between Arduino and Frappuccino? In the Arduino side, the board information is selected in the IDE, also the communications information is selected in the IDE, whereas in Frappuccino, that information is embedded in the source, in the class structure, the extends what your base board is. Arduino converts Java and Java type syntax into C and C++, and then it compiles that using GCC. For Frappuccino, the Java is compiled by Javac, or JAX, or whatever Java compiler, and the bytecodes are processed by Muvium. So Muvium is a ahead-of-time compiler, and I'll talk about that in a second. They both run on 8-bit micros, and they both program the embedded microcontrollers over a bootloader. So the Frappuccino project is an Eclipse project. It's an open source project, which was just put up. It's hosted at Google Code. The URL's there, but you can't quite see it. It's a Java chip Frappuccino. Oh, you can see it up there fine. So it's based on this template that Processing put out. So this Frappuccino project itself, there's several tasks that we do with it. First of all, of course, it's deploying to this library, which can be plugged into the Processing IDE. But you can also do more with it. And we talked about Arduino being an island, and you're sort of stuck there. You can't really do much more. Here, this is the first step outside or off the island. You can work directly with Eclipse for developing Arduino type applications. And okay. So you can actually develop directly the applications in Eclipse now, which is quite new. You're a DevOps, right? So you guys know about Eclipse, you know about Netbeans, you know about these sort of things. That's quite new for a lot of the entry-level Arduino guys. But that's a nice idea. You can start with Arduino and you can migrate somewhere with those same skills. The other thing that you can do with the Frappuccino library is you can run unit tests. And so we're developing the idea now of, I guess, building testable release versions of Arduino. It's one of the things that I've noticed the Arduino group has struggled with is testability and unit testing and formal programming, these sort of things. So this allows us to do that with this framework. So if you're working with Eclipse, you can run an Arduino Frappuccino program just like any other program. You just right-click on it and run it, or you set up your Eclipse configuration and run it. So here's what a program would look like inside of the Eclipse. It's exactly the same as what it would look like inside of the processing, except with one extra line here at the bottom, the Muvium programmer program. And this is the entry point where the Muvium compiler gets invoked. And from there, it uses reflection to find out the information about the class and to call the Muvium compiler, which prepares the binary, and that then invokes the bootloader programmer. Depending on your board, the V18’O, which is a development board that we have, which uses a USB, and then it'll automatically find it, the USB board, and program it. Equally, you can run the unit tests in the same way. There's two sets of two starting points for the unit tests. The Java version, of course, so you can run the unit tests on the Java side, and that's very useful when you're first setting up the actual test itself. You run the test, and when you want to confirm the same functionality with the embedded version, you run the unit tests using the Muvium target. I've done it again. So these are done with the integrated unit test suite with JUnit, and it's the Muvium toolkit has got a unit test runner, which does the legwork of taking the compile code, compiling it, programming it, getting the results back, and allowing you to validate the result. Naturally, Frappuccino, being Java, it can run on any Java platform. So if you're using Netbeans or JEdit or BlueJ, some of these, again, educational, simpler versions, or even a command line prompt, you can continue to work. So I guess the idea here is to be more inclusive with Arduino, not just one place, but many. Oh, gosh. Another part of the success story for Arduino is the idea of a shield. Now, a shield is it's a type of modular hardware. It's an hardware object of a sort. Now, a shield is typically delivered with an API, and so you can plug a shield into the Arduino platform and then use the API to use it. I talked a little bit about Virtual Breadboard earlier. Virtual Breadboard takes the shield format. We have a product called the iShield, which is this thing here. And this shield connects with Virtual Breadboard and allows you to wrap a virtual circuit around your embedded micro. So whether it's Arduino or the V18’O or the ChipKit 32 or Arduino, you can use it with the Virtual Breadboard software using this abstract hardware. And that gets really cool when you start building real things. You can integrate. I have a little toy here somewhere. Let's see if I can make it work. It's nearly Christmas, isn't it? So inside Virtual Breadboard you have a little circuit board that you can design and build, but it's makeable. So this is a PCB service we offer. So you build makeable breadboards inside Virtual Breadboard. They can emulate, and then you can make them for real. So Virtual Breadboard there's two versions of Virtual Breadboard. Virtual Breadboard Express and the full version of Virtual Breadboard. Virtual Breadboard Express runs in, is mono-compatible, which means you can run it on your favorite operating system, whereas Virtual Breadboard only runs on Windows. Again, trying to be inclusive. We have special support for these Frappuccino chips. And the idea being you want to be able to emulate and develop virtually, but still have the chance to build physically. Full Virtual Breadboard only runs in Windows, but you can has some additional features. You can emulate the Frappuccino API level. So a lot of people say, well, why can't I completely simulate the Arduino environment? When you completely simulate a microcontroller, all its peripherals and so forth, it gets it's a huge undertaking. So what we've done is sort of use the Java API level to create an emulation layer, which can run both in the PC, in the emulated version of Virtual Breadboard, but also for real, because we have the JVM for the embedded micro. Virtual Breadboard supports a few extra features like debugging. Now, interestingly, a lot of users of Virtual Breadboard have become interested in the Arduino version of it. Inside Virtual Breadboard, we have the Frappuccino emulation engine, but of course, it's based on Arduino. It's the Java part of Arduino, but still extremely useful for developing Arduino applications, and a lot of people use that part. So it's become quite interesting to people because Arduino itself doesn't have some of these debug features that Virtual Breadboard does. So you can set breakpoints, you can single step, you can freeze your application as you're going along. It's quite a handy thing. So of course, Frappuccino is also built into Virtual Breadboard, so you can deliver the application from Virtual Breadboard as well. So this is all about showing how you can work with Frappuccino in different ways. You can work with it, because it's Java in any environment, you can work with it in Virtual Breadboard or in Virtual Breadboard Express. So this is just about being more inclusive in the way we can work in physical processing. And the engine that makes it possible is this micro virtual machine, which I've developed. Now, I've been working on that in various forms since 2003. It's an ahead-of-time compiler for 8-bit microcontrollers. So it's fully implemented in Java, and I've actually implemented the JDWP for it as well, which means you can plug that into Eclipse or so forth for in-circuit debugging. And the current target is the microchip PIC18 family, which we supply pre-programmed. So you just plug it into your application, and then you can use the tools to program the device. So again, this concept of making physical computing more inclusive, using a broader range of tools, using interoperating in a broader number of ways. So it's more in tune, I guess, with this social idea that we all like to work in our own way, not only in one particular way. So, since you guys are all red-hot Java developers, one of the reasons to come and talk about this is to interest you in joining the development effort of the Frappuccino library. And at the moment, we've ported many of the Arduino libraries, but there's still many others to do. And also to take it to the next level, build some really cool physical computing libraries, some of these stacks, graphical application stacks, and wireless stacks in particular. So if this is in an area that's interesting to you, then by all means come along to the Google group and download the code, play around, and maybe pick something to contribute to. And that was it for the presentation. Any questions?
Do you foresee future support for the other family of Arduino processors, like the Intel?
Do I foresee support for the Arduino-specific devices? Yeah. Presently, the target for the Muvium compiler is the PIC micro, right? If there is interest, it can also be ported to other platforms. In fact, I have done some initial work to Hello World it on an AVR, and also for an ARM. So there's definitely scope for it to be ported to other platforms. I've also worked on some very small footprint FPGA cores, so that's another area as well. And also considering doing a multi-core type version, so focusing on using the fact that Java's got the natural threading concepts in there, and that maps quite nicely to a multi-core processing device. But it's been a long time developing it to get to where it does work now on the PIC18s, and so first of all, I'd like to grow that out, considering the microcontrollers are somewhat of a commodity. I mean, one versus the other, it's hard to choose. Just by chance, it happened to be the PIC Micro. This began, the first version ran on, I don't know, 16F877, a very long time ago. So it's just been an evolutionary thing rather than a specific. For example, so in other words, this predates Arduino, and happens to map closely to where Arduino's gone. But yeah, certainly scope for it, but I'd like to get some interest for what's been done already first. Any other questions?
What are some of the coolest things you've seen done with an Arduino?
Oh. The coolest thing I've seen done with an Arduino is to... the question is, what are the coolest things I've seen done with an Arduino? Well, the coolest thing I've seen done with an Arduino is to drive my ice shield here and to build virtual applications around the Arduino processor. So the other cool thing I've seen done with Arduino is to program it from virtual breadboard. So I've actually been more of the tool provider for other people who make cool stuff with Arduino. What's the coolest thing you've seen with Arduino? Oh, quadcopters. They're cool. That's true. They're very cool. There's been some very cool things done with Arduino. Anyone else? Okay. Well, look, thank you very much for your time, and hopefully we'll see some of you pick up and maybe contribute to the Frappuccino libraries, so we can broaden the base of what Arduino can do, and the developers who might be interested in physical computing. So, thank you.